Hello class, welcome back. Um, we're gonna enter our week 10 material. Now, today, this week, we're gonna talk about the introductions to algebra. And this week, we will particularly concentrating ourselves to look at algebraic expressions. We haven't get to the algebraic equation yet. That's something we will do next week, the next 2 weeks. And what's so special about algebra is that it is significantly different than what we've been doing for the past 6 weeks or so. Because remember as well, how we begin our semesters with doing a lot of algebra, sorry, not algebra, but fractions, decimals, and all that. What you simply do in those week 1 to 6, something like that, is that you've been looking at different number theories, fractions, decimal, like that. When you do all these when you do all these problems, what's so special about them is that you can always get into like answers by following the steps or the principles of doing such expressions. So that's what we've been doing for the past 6 weeks or so. But now that when we enter into the realm of algebra, the realm of algebra, what it is that algebra is pretty much a study on relationships. It's study on uncertainty. Okay, and what makes algebra so distinguished is that there's always a variable when we deal with algebra. Variable in mathematics, we refer that to a letter of alphabet that is used to stand for a quantity that is unknown or vary. Okay. Most likely, in a lot of cases, the variable will be represented in like x, y, z, a, b, c, something like that. And so the first thing we're going to soon work on is to evaluate in algebraic expressions. But before that, there are still a few notes where you guys have to take. Under variable, there are the letters of x, y, z, but also there's another aspect you have to know is what we call coefficients. What it is that coefficients refers to the numbers that is multiplied to the variable. Okay, what do you mean by that is, let's take a look at the example of, let's say I have 2x squared. It's an algebraic term, but in this case, the 2 is multiplied to the 2x squared. So then, the coefficient in this term is 2. Sometimes we might see some bigger numbers like 12x cubed. We can identify that the x is a variable because it is a letter of alphabet, but the numbers comes before it, or the numbers that's multiplied to it, in this case is 12. So coefficient is 12 in this case. Okay, now we'll jump to evaluating algebraic expression. What do you mean by that is that, let's say I give you an algebraic expression, for example, number 1. Let's say that is 4x plus 2y, okay? And I tell you to evaluate it by let x equal to 3, let y equal to 5, something like that. So now what do we have to do is that we just have to plug in the value of x with 3 and the value of y with 5. So let's say, to continue with question number 1, this will be 4 times x, which is 4 times 3 in this case, plus 2y, which is 2 times y. In this case, it will change to 2 times 5. Now can we go back to what we've done in the beginning of the semesters, which is just multiplying and adding. So then 4 times 3 is 12, plus 2 times 5 is 10. Altogether is 22. Okay, so we just evaluate the algebra expressions with x of 3 and y of 5. It's not too bad, right? So let's do another examples and then we'll keep going. Let's say we have 8a minus 12b. You have to know that a and b represent our variables in here. Now I'll give you the second part of the instructions, which is to let a equal to 10 and let b equal to 4. Okay, so continue with question number 2. It will be 8 times a, 8 is 10 in this case, minus 12 times b, b is 4 in this case. Okay, continue with the math. That math, that would be 80 minus 48. Do your math, that will become 32. So that's what we mean by evaluating algebraic expressions. Please get yourself familiar with this type of instructions. In this case, that's an evaluations to the algebraic expressions. Next thing we can talk about is simplifying a variable expression. Okay, we're going to move on here. Now we're going to talk about what we call by like terms. Okay, like term in mathematics, or specifically in algebra, we call that like term are the terms with the same variable part. For example, let me give you this. Let's say x plus x. Can we see that x as an as a variable and this x as a variable, they are identical. So we can say that these two terms are like terms. And so what we're going to do about it is x plus x give you 2x. Just like if you have 3 plus 3 is going to be 2 times 3. If you follow this rule, a lot of things you can combine like terms. Let's say x squared plus 3x squared equal to what? Okay, just an additional note that whenever there's no coefficient to the variable terms, it is automatically assumed to be a 1. Okay, because before that it's only a x squared. X squared is a variable term, but we don't see a coefficient here. That doesn't mean that there's no coefficient. It just means that the coefficient is 1. Now to combine like terms, is 1x squared plus 3x squared, that will give you 4x squared. Same thing with the subtractions. Say I have 3a squared minus 2a squared. A squared is the like term, so we will subtract it to be 3a squared in this case, because I'm only subtracting the coefficient. Well, we'll get to the multiplications and the divisions part of algebraic expressions maybe next week. But at this point, just keep in mind of the combined like terms as if adding and subtracting algebra. Okay, now we'll continue with another exercise on simplifying algebraic expressions. For example, number 1, let's work on this. 8z minus 5 plus 2z. Okay, can we identify the variable terms first? Okay. And okay, let's add it. So 8z plus 2z, that will give you what? 10z. What's left in the question is the minus 5. And as a matter of fact, we always call the terms without any variable to be constant. So we call this the constant terms, which is a term that has no variable. Okay. Next, number 2, let's try this. I have 12a minus 4b minus 8a plus 2b. In this question, then, there are 2 different variables. First of all, we have the variable of a, and then we have the variable of b. So to combine like terms, I can only do add or subtract to the like terms. In this case, a has to minus a, b has to minus b, or add. So let's rewrite the questions then. It starts with 12a minus 8a. I am simply moving the minus 8a from the third term in the questions. Now I shift it to my second term, minus 4b, which is this, plus 2b. Why is that? Is that I want to make them next to each other before I do any subtractions, additions. Okay, now 12a minus 8a, that will be 4a because I'm only subtracting the coefficient. Okay, what's next? What's next is that I have another operations that deals with the variable of b. In this case, I'm looking at negative 4b plus 2a. So negative 4 plus 2, if you want, you can go back to the notes on integers. But this will become negative 2 or minus 2b in this case. All right, let's do another example. Let's see. Okay, let's work on this one. 6xy minus 8x plus 5x minus 9xy. In this case, again, we have 2 different variables in here. First, we have the variable of x and x, and then we have xy and xy. Okay, x is not xy. They are not like term. X and x can be the only like term in these questions. So is the xy and the xy be another variable in these questions. Now let's work on it. So that will be 6xy minus 9xy minus 8x plus 5x. If you take a look at it, I did not change anything but the orders of how the question is arranged. Now let's go back, let's continue with the math. 6 minus 9, that is a negative 3xy. Okay, so I'm done with that. Let's try to cross it out, not to confuse ourselves. What's left is a negative 8x plus 5x. Negative 8 plus 5 is a negative 3x. Okay, that's that. Okay, now before we jump into a little bit harder extent of simplifying expressions, there's something I've talked to you guys about, which is the distributive property. Okay, what is that? Is that remembers in what we learned about the orders of operations, which is the acronyms of pandas, there's something that is involved, which is parentheses. Okay, so let's do some recap. Okay, let's say I give you 2 times parentheses of 5 plus 3. Okay, let's try to do it. Well, according to pandas, you should focus on the parentheses first. So then the next step should be 2 times the 5 plus 3 is 8, which gives you what? 16. Well, there's another way of doing it, which is 2 times 5 plus 3. According to the distributive property, what it is that, can we see that the 2 is outside of the parentheses? And what do you mean by distributes is that we have to distribute to the 2, the factor of 2, to the first term in the parentheses, as well as the second term in the parentheses. So the work will look like then that will become, because it is essentially 2 times, I didn't explicitly put the multiply over there, but it is multiplications. It will become 2 times 5 plus 2 times 3. Can you see that 2 times 5 is when 2 is distributed or multiplied to the first term in the parentheses, plus I'm simply following the signs within the parentheses, plus what's next is that the 2 is distributed to the 3, the second term of 3, like that. Okay, let's do the math. 2 times 5 is 10, plus 2 times 3 is 6. Altogether, you still have 16. Why is distributive property important is that when it comes to algebra, you cannot add a variable to a constant. For example, let's say I have 4 parentheses, which is multiply, x plus 5. Okay, well, in our first examples, obviously, if you have odd numbers, everything is has its own designated numbers. You can add all of that, multiply and all this. But in this case, no. Look at what's happening within the parentheses is that you have a variable of x. So let's put it over there. Okay, within the parentheses, you have the variable of x. I'll use v to represent that. And then you have a plus 5. That plus 5 is a constant. Again, constant is the term that has no variable, and you just cannot simply add a variable to a constant. It doesn't work that way. So that's why we have to apply the distributive properties like that. So 4 times x will become 4x, and then plus, stick with the sign within the parentheses, plus 4 times 5. In this case, that will become 4x plus 20. Alright, let's work on another example right here, just to make sure you guys know what that is. Let's say I have negative 5 parentheses 2x minus 4y. Again, the numbers outside of the parentheses has to distribute. So the first term, in this case minus the factors outside multiplied with the second terms. Okay, so that will become negative 5 times 2x minus negative 5 times 4y. Okay, negative 5 times 2x. Again, go back to the notes on integers. In this case, specifically on the multiplications on integers, when we have negative and a positive multiplied together, you always yield a negative answer. So in this case, that will become negative 10x minus negative 5 times 4y. That is a negative 20y. Now, to make things straight, that will become negative 10x minus, well, minus an integer, so apply KCC. Keep, change and change. That will become a plus. And then negative 20y will become a positive 20y. That's your final answer. For all your homework assignment, as well as take-home quiz and tests, do not leave your final answers like that. It is not a tolerable form of final answers because I don't want to see minus negative. It looks funky enough to a point that I might not know what that is. So then, apply KCC. That's how you get to the final answers with a precise understanding of what that is. Okay. Okay, the last thing we're going to talk about in here is that we will apply distributive properties in our simplifying algebraic expressions. Okay. Okay, take a look at this. 5n minus 3 parentheses 2n minus 4. Okay, now, well, let's copy the 5n first because there's nothing we can do about it. But before we put anything else, look here, we have to distribute. In this case, we'll actually distribute the entire thing of -3, or we can read it as -3. -3 distribute to the first term to the second terms. So that will become -3 times 2n minus 3 times -4. Okay, now let's work on it. Well, 5n will always become a 5n. In this case, -3 times 2n will become -6n. Also, we have -3 times -4, which is +12. If you don't want to read that as -3 times -4, another way of doing this step is that, well, 5n minus 3, well, in this case, the second term has to be -6n anyways, so it doesn't matter. If you want, you can, the third term, you can read it as minus 3 times -4, which is -12. So altogether, you still have 5n minus 6n plus 12. So please don't get confused about it. Now, look at these steps. We have something to combine like terms, which is the 5n minus 6n. That will become negative n plus 12. Okay. Now let's work on another examples. What about 3 parentheses c minus 2 plus 2 parentheses c plus 6. Okay, apply distributive properties. It will become 3n minus 6, 3 times c, 3 times -2. That's how I get 3n minus 6 plus, well, this will become 2c plus 12. Okay. Okay, sorry, the first variable is c. Now we can combine like terms because I have 3c plus 2c and then -6 and plus 12. We can combine like terms in this way because, well, c and c are variable. And the -6 and plus 12 are considered the constant terms. Again, the term that has no variable, they are considered constant terms. So overall, constant terms can also be combined like terms. Now 3c plus 2c will give you 5c. Minus 6 plus 12 will give you +6. Okay, so that's how we will that's everything we'll work on this week. Again, just a recap. Please familiarize yourself with the terms like variable, coefficient, as well as the constant terms. Again, constant terms right here. I put the definitions here. You need to know how to evaluate algebraic expressions. That is, you'll be given an algebraic expressions, and then on the side you'll be given what each variable stands for. And then we move on to simplify algebraic expressions, which is combine like terms, as well as practice your distributive properties. Okay, those three things will become essential next week when we talk about algebra equations. Okay, so have fun and good luck on your homework.